All right, what's up, guys? This is the rates question from 2015. And in this question, we have rainwater flowing into a drain pipe. And we have R of t, which is the rate that it's flowing in. We have D of t, which is the rate that it's flowing out. And we have an initial condition at time 0. There's 30 cubic feet in the pipe. All right, part A asks how many cubic feet of rainwater flow into the pipe during the 8-hour time interval from 0 to 8. So if you want to know how much rainwater flowed in, all you have to do is integrate the rate that it's flowing in at from 0 to 8. So the integration from 0 to 8, this is just math 9 and button pushing, and you get 76.570 feet cubed. Part B is the amount of water in the pipe increasing or decreasing at time 3. Give a reason for your answer. So we have an equation for the rate that it's coming in and an equation for the rate that it's going out. So I'm just going to compare those guys. So at time 3, the rate that it's flowing in is 5.086, and the rate that it's flowing out is 5.4. Since 5.4 is bigger than 5.086, that means it's draining out faster than it's coming in, so it's decreasing. All right, part C is over here. And it says, at what time between 0 and 8 is the amount of water in the pipe a minimum? Justify your answer. So again, we have a min or a max on a closed interval. So you got to check your endpoints and when the derivative is equal to 0. All right. So first, I wrote an equation for the amount of water in the pipe at any given time. And that's equal to what you started with, plus what comes in, minus what goes out. Okay. So I can plug a 0 in, and I can plug an 8 in, and that gives me my endpoints. Now I've also got to consider when the derivative is equal to 0. So when I derive this guy, well, the 30 derives away, and then the second fundamental theorem is happening right here. So that's why A prime of t is equal to R of t minus D of t. Set that guy equal to 0, graph it, and you'll see it cross the x-axis at 3.271. So now I take that 3.271 and plug it in for my time values, and I push buttons, and I get 27.965, which is clearly the smallest number in that table, so that's when you've got a minimum. All right, part D, it says the pipe can hold 50 cubic feet of water before overflowing. For t is greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Find the time W when this happens. Okay, so again, I'm pretty much just rewriting this equation, but instead I'm replacing my T's with W's because it's saying W's the time when this reaches 50 cubic feet. And so I just have what I started with plus what comes in minus what goes out equals to 50. And I can stop right there because it says write but do not solve. All right.